Okay, continuing where we left in the last video, continuing with section 4.2. We were talking about the periodic table and the arrangement of the 118 elements in the periodic table. The other thing that you'll notice is that all elements, you see a number right on top of the symbol of that element. And that is a characteristic of that element. That's how you identify the element, all right? So element number 1 is hydrogen, element number 2 is helium, and so on. So as I mentioned, the majority of those elements among the 118 elements are metals. And then you have the non-metals and then the metalloids, okay? That separates the metals from the non-metals. Now, most metals tend to be solids at room temperature. They have quite characteristic properties of metals, like they're good conductors of heat and electricity, they're shiny. The exception that of a metal which is liquid at room temperature is mercury. Now, metalloids have properties that are kind of in between. So they are somewhat conductive, and so they are known mostly as semiconductors, and therefore silicon is used in the semiconductor industry, especially in the making of the silicon chips. And then the non-metals are mostly gases at room temperature. If they are solids, they're kind of powdery solids like sulfur, like a yellow powder kind of looking solid. They're called as amorphous because they don't have a regular form. Okay. All right. And then I talked about the lanthanides and the actinides. So the B group elements are called as the transition elements, and the lanthanides and actinides are called as the inner transition elements, okay, because they kind of fit in here, and they are always put separately from the main periodic table down below here. Okay. So groups contain elements and they have very similar chemical properties. Sometimes physical also, they have certain characteristics that are kind of similar. And then you have the 7 periods. And as I explained, that the first period has 2 elements. The next 2 periods have 8 elements, and then you have 18, and then finally 32 when you add in the lanthanides and the actinides. So you basically have 2 elements in the first period, and then you have 8, and again 8, and then when you come here you have 18 because of the fact that you're adding on these 10 transition elements, and then again you have 18 here because of the transition elements. Now over here, because of the 14 lanthanides, it becomes 32. Now period 7 should also have had 32. However, you see these are blank here. These are elements that are artificially created. They don't really exist at the present time. So that it varies the number of elements here in the 7th period. It can be anywhere from 29 to 30 and so on. All right. So it's basically those numbers 2, 8, 18, 32. And there's a reason for that. When we look at the way the electrons are arranged within the atom, those numbers will make sense. Okay, so we talked about group 1, the alkali metals, group 2, alkaline earth metals. These groups don't have any particular name. Group 7 does. Halogens, the noble gases, group A. The representative elements are all the A group elements, And then the B group elements are the transition elements. Okay, so the group numbers are at the top of the columns. And so this is my preferred labels for the group numbers. And then you have the B group elements, the transition elements. We'll be talking more about the representative elements, especially when we look at bonding, etc. Transition elements, there's we do encounter it a little bit, but not as much as the representative elements. This alternative system of numbering, you can use it. However, again, my preferred is using the old numbering system. Okay. So we talked about the groups and periods. Now, how do you identify an element? Suppose the question says, what is the element in period 4 but group 2A? So that would be calcium, because that's period 4, group 2A, all right? So you can identify an element based on where it's located within the period and its particular group. So we talked about the alkali metals, the alkaline earth metals. Alkali metals are the most reactive among the metals, followed by alkaline earth metals. No common names for these groups. And then the halogens are the most reactive among the non-metals. Noble gases are unreactive. They are very stable. And then the transition elements are quite different. They behave very differently compared to the representative elements. All right, so group 1A are the alkali metals, lithium, sodium, potassium, rubidium, cesium. And one of the characteristics is that they're kind of soft, so you can actually cut them with a knife, even though they're metals. They're shiny, of course. They also can be characterized with a flame test. So you can take a piece of this metal and apply it to a flame, like a Bunsen burner flame, and they give characteristic colors to the flame. All right, sodium makes the flame like a yellow, orange kind of yellow glow to that flame. Potassium will make it purple. So those are ways to identify these elements if they're present in a substance. The other thing is that these are very reactive metals. So they can even react with the moisture from the air and react quite violently. A lot of heat is generated, very highly exothermic type of reactions. And so a lot of the times, if they are kept in a lab, they are stored in like containers in mineral oil, so as that they are not exposed to the moisture from the atmosphere. All right. Group 2, the alkaline earth metals. Beryllium, magnesium, calcium, strontium, barium, and radium. Radium is radioactive. Beryllium tends to behave less like a metal and more like a non-metal, and we'll come to that a little bit later when we deal with bonding. These are also very reactive metals, but little lesser reactive compared to the alkali metals. So these can, of course, be, you can have them out on a shelf and they won't react with the moisture from the air or anything like that. They do react with water, but only when water is in the vapor state, as in steam. Then they can react with water. Whereas the alkali metals will dissolve into water and it's highly exothermic, It's a pretty violent reaction. And that's not the case here with the alkaline earth metals. Again, a lot of them give a characteristic color to the flame. Calcium and strontium make the flame red, and so the red from color in fireworks is from strontium. Barium makes the flame a kind of a greenish color. They call it apple green, like the Granny Smith green apples, that kind of color. Right, and here you have the halogens, group 7, and as you can see here, you have chlorine, which is this greenish yellow color, bromine, which has that reddish brown, and then iodine, which is a solid. It's put into tincture of iodine, and it's an antiseptic. And they are very reactive. These nonmetals are very reactive. The other thing that you notice here is you see chlorine is not written as Cl, but rather as Cl2, and so is bromine, Br2 and I2. So these are elements, but they exist in the diatomic state, all right? So chlorine, bromine, iodine, fluorine, nitrogen, oxygen, and hydrogen are elements that exist in the diatomic state at room temperature. Okay, identify the element described by each of the following groups and periods. Group 7A, period 4. So period 4 is in the carbon, period 4, group 7A. Okay. Going back. Oops. Period 4. So period 4 and then group 7A would be bromine. Okay. So it would be A. Group 2A, but period 3. Period 3 would be magnesium. Okay, because it's beryllium and then followed by magnesium. Group 5A, but period 2. Okay. Group 5 would be, it would have to be, period 2 would have to be nitrogen. Okay, so that's C. Yeah. So group 7, period 4 is bromine. Group 2, period 3 is magnesium. And group 5A, period 2 is nitrogen. Okay, so metals are on the left side, non-metals on the right side, and then you have the zigzag line where the metalloids are located. So some of the characteristics of metals are that they're shiny. Ductility means that you can shape them, hammer and shape them, okay? So you can hammer them and then draw them into wires, all right? I'm sorry, ductility is drawing them into wires. Malleability is hammering and shaping them, all right? So they're malleable and ductile. Ductile is drawing them into wires like copper wires for conducting electricity. So they conduct heat and electricity. Most are solids, the exception being mercury, which is a liquid. Non-metals, on the other hand, are bad conductors. They're better as insulators. Most of them are gases, and like I said, they're gases or liquids, etc. at room temperature. So metals are very dense. They have high densities. Non-metals have low densities, low melting points, whereas metals would be the opposite, high melting points. All right, we'll stop here, continue this again in the